Hi, I'm Dr. Andy Forelli in Huntington, New York, and in Melbourne, New York. What I'm going to show you here today is the Titronics Adjustment Simulator and the stand and headpiece that go with it. What this does is it analyzes, graphically represents all components of your thrust when you're doing an upper cervical adjustment. So here's the unit right now. I'm going to pan over this. Okay, this is the actual receiver, manufactured by Titronics. It's fit into this headpiece here, which I built. It's a drop headpiece. It's adjustable with its tension on the other side, and it can also be used for knee chest. And the stand that we built to accept it, it's made out of structural steel, weighs about 90 pounds. It's very stable. So the way this works is very simple. All right, so we have it set up for toggle recoil right now. So what we're going to do is we're going to demonstrate a toggle recoil adjustment on the simulator and show you exactly what it is that it shows us. Now, I just happen to have this rear projection screen up from a Super Bowl party, so I haven't adjusted anybody or practiced on this since yesterday, so let's see how well I do. Well, didn't drop the headpiece, so that doesn't count. So let's do it again. Okay. Let's try again. So you can see that you're not practiced, so there we go. All right, so what we're seeing here, come in close to the graph, okay? What we're seeing here on this is we're seeing the total speed of the adjustment. The speed is about 60 to 70 milliseconds. The total amount of pressure is about 29 pounds. That's the first peak. But we can see that the second peak right here, the baseline of the second peak right here, that bottom of the second peak starts above the baseline. That means my arms were still traveling downward when the headpiece bottomed out. That was not a proper toggle recoil adjustment, so we'll see if we can do that correctly the next time. All right, reset it, we'll do it again. No, didn't trigger it, didn't drop the headpiece because I didn't go down, didn't make enough of an excursion. All right, this is how you test yourself and make sure that you got it together. Did it again. Try one more. There we go. All right, now this is a proper toggle recoil adjustment. Come on, come in and show you this one. All right, so here we go. Once again, 60 to 70 milliseconds. That's how fast the toggle was. About 23 pounds, about 23 pounds worth of force. And we can see the second peak right here. The base of the second peak starts at or below the baseline. That means when my hands were already traveling up when the headpiece bottomed out. And that's a proper toggle recoil adjustment, because if your hands are still traveling downward when the headpiece bottoms, basically what you're doing is you're bottoming the patient's atlas out. You're not delivering a proper toggle recoil adjustment. So we're going to change the parameters of the simulator now. We're going to change it for a knee chest adjustment. We can see if we can deliver a proper knee chest adjustment on somebody right now. All right, so now the headpiece is down, and knee chest adjustment is a little bit different style. All right, here we go. This is what a proper knee chest adjustment looks like. Once again, very quick. Knee chest adjustment is a little bit slower. One of the reasons why BJ said that the toggle recoil was a preferred adjustment. We're talking about 100 milliseconds. We're talking about 181 pounds worth of force. But the thing about knee chest adjustment that makes it a toggle recoil is that by how sharp the incline is and how sharp the decline is, it tells you how quickly the adjuster was in and how quickly they came out. And that's how you really get the toggle recoil out of a knee chest adjustment. You have to be in and out quickly. You also want to have a sharp peak up at the top. Two components of the knee chest adjustment are the contraction of the triceps muscles and the pectoralis muscles combined simultaneously with a body drop. And if you do a sloppy adjustment, the simulator will show you the incoordination between those two components of the knee chest thrust. Let's see if I can make myself a sloppy adjustment, and maybe we can demonstrate that. No, well, it's a little bit sloppier, so here's where you go. if we come in here, you're going to see it's a lot slower, right? The incline isn't quite so sharp. The decline isn't quite so sharp. We don't have anywhere near the amount of force, 148 pounds. And the peak here is flatter. The flatter peak is telling you that the thrust was not coordinated. Two components of the thrust were not coordinated. Let's see if I can make a little bit more disparity on that. No, I still can't do it. I can't give sloppy adjustments. Only the students can give sloppy adjustments. All right, that's what I want to see. Okay, here we go. Now, if we come in here and we look very, very closely at the peak of this adjustment, we can see that at this peak, it really looks like two peaks. We've got a peak right here, followed by another peak or plateau. What that is showing you is that we don't have a very sharp peak at the top of this particular graph, and that's showing that the two components of the thrust, the body job component and the contracture of the pectoralis and the triceps muscles, were not coordinated. So what you're essentially looking at here is two thrusts that occurred within this first portion of the thrust occurred at about 80 milliseconds, second portion, those two incoordinated components of the thrust occurred in the span of about 20 to 30 milliseconds. So now we're going to do a proper thrust here again to show you what's going on with that. All right, now here's a proper thrust. All right, look, very quick, 100 milliseconds to the top, 180 pounds of thrust, in fast, out quick, nice sharp peak at the top. That's what it's supposed to look like. So that's Titronics Adjustment Simulator. It's computerized. If you guys got any questions about it, we can talk about all the different components of the graph and what the graph shows. But the graph essentially is going to show you speed, it's going to show you depth, it's going to show you force. The only thing it doesn't show is torque, but the puck at the top of the simulator is movable. It's readily discernible. If somebody's going to deliver torque, you can see the puck spin. So let's do one more with torque. You can see the puck spin. There we go. So that's a nice sharp adjustment. It's even better than the last one. Look, nice quick peak up at the top, about 178 pounds of thrust. In quick, out fast. That's really all you need to see about it. All right, this is a rather impromptu video done at the end of a Super Bowl party. I hope it doesn't look too professional. I am wearing my Sherman shirt. If you guys have any questions, please feel free to give me a call. Thank you very much.